All right, so I thought I'd just try to record a little bit of my thoughts when I was solving this task. So that code challenge come from these guys. I don't know how to pronounce his names. Clement Mihailsku. Uh, code challenge that was done with Ben Awad. I thought I'd give it a try myself. So the challenge is that you get an input in the form of a matrix. So it's like this one. And you're supposed to remove all the ones that are not connected to the border of this matrix. So this one here is connected to this one, but this one here doesn't have a connection to the border because we don't count diagonals. So it's not connected to this one. It would need to be connected to either this one or something else in order to be considered connected. So there's an example output, and here is an example of the islands that get removed. So example, this one should be removed. This island here should be removed, and these two down here. Okay, so I wrote the driver code here, just feeds in the data, which is a vector of vectors. And then we have the function. So we'll take it in there, and we're supposed to do this task then. So I ended up going for creating graphs for this task, and then I wanted to use some kind of traversal code to figure out which islands I need to remove. So the first thing I do is let's head over to the actual structure of the graph. So it's just the children, and then we have some data that we will be able to use later on to decide which ones to remove. So that's the way that the graph structure now looks like. And then if we head on back down to the actual thing that does something. Okay, so we need to create the graph given this matrix first. So I started to think of this like I wanted to create graphs for all the ones that are connected. So I start at the frame of the matrix, so the outside frame, and I got my left, my right, my top, my bottom, and then later on we're going to need a set to make sure we don't visit nodes that we have already visited before. Then we start off with just going through the frame here. We start at the left side and push all of these into the graph. So the head graph is going to get all of this stuff inserted into it. So you see here, pushing back all those nodes. Here we are just creating them, and we only create graphs for well, I call them islands, the ones that have a value of 1. So we check for all of that, and we go through the left, the right, the top, and the bottom. And once we have that, we start to traverse this graph that we have to find the ones that are connected to the border. And we do that in this, I call it visit children. So here we have the matrix. Then we have this visited node. So we make sure that we don't visit a node that we have already visited. And then I used a current circle. And what I mean with that is if you're a 0 when you're starting, you're on the outside here. You're on circle 0. When you advance into here, you're now in circle 1, and here would be circle 2. And then we have the rule, right? Which ones are adjacent. So we have the top, the bottom, left, and right. And then we have a rudimentary check here to make sure we don't try to check for anything that is out of bounds here. So we check that that's not out of bounds, and then if it is, then we're going to do some further checking. So create a little function here to check and create new nodes, new child nodes for these border guys here. So then we go to the create, check and create new nodes. Just carries this data with it, and then it has a row offset and a column offset. And that is like if you're going to visit the one that's on top of you, the row offset would be -1 here. If you were visiting the one that's below you, it would be +1. So the first thing we're doing is, of course, check that we haven't already visited this one. And then we check, okay, this current circle, yeah, it's there, but we're not using it anymore. So I should remove this code. Yeah, this was my my first attempt at this, where I had a sort of another strategy. So I'm gonna go ahead and remove this current circle thing here. Just forget about that. We are just going to try to find anything that is connected to these ones. We don't care about no circles here. So forget about this one. So what we actually do is we check that we are not out of bounds again. So I probably wouldn't really need this code because we're doing it down here. But that was the thought of this, that you shouldn't go out of bounds with the nodes that you're trying to visit. And then we check. So now let's say we are at one of these. I'll copy some code over here just to make it a bit easier. So now we will actually check. So if we were to start, we created this left section first, which are excluding the top and the bottom. I created the left here first. So we started this one 0. That's not going to be something we're interested in, not this one either, but this one. So we will start here at this one. When the order is, it goes, I think it is top, bottom, left, right. So we're going to come in here with the right one. And then we're going to see if that one is a 1. If it is, we're going to insert it into the nodes that we have visited. And then we have some dead code here. This code is not relevant. We just care about the ones that we have visited. And if this has a value of 1, we know that we want to create a graph for this. So we're going to add it, and then we're going to try to visit the node that we just created here. So the one that we just created is in here, right? We added it to the one we came from. So we came from here, and we added it to the child, which is m nodes here. And then we're going to go and do the exact same check here for this one. So all the adjacent ones that we can find here, we're going to add. So is this one? No, it's 0, so it's not interested. So here it would kind of end. So that is the idea with that. And what you're going to end up with having is a top node, which has like all these border ones. And then you will have some that will span into a graph here. So this one and also these one are going to form a graph. And here you're going to have a graph that is including this one as well. Okay, so I hope that wasn't too confusing with some of the dead code still in here. Let's head back to the function that's actually going to remove the islands. So now we've created the graph. Now we want a set of islands that we are going to keep, which are going to be the islands that is in this graph that we've created. So we simply traverse the graph and store all of the pairs in here. So here we have our set, and then we start off somewhere and we insert the pairs. So this is where we use this row and column information, and we simply insert it into that. And once we've done that, we can iterate through this matrix here and check if there is a, so we just run through the whole matrix, and then we check if there are any islands here that are 1 that we could not find in the islands to keep. And if that's the case, then we set them to 0. And that should be it. So let's see. Let's build it. And then let's not commit it to GitLab. So here we can see we have the example output and input here. So we can see here that, okay, the input is here, and the ones that got removed, you can see that this one got removed, which is correct. We can see that this one got removed as well. That's from here. All right, good. And then the other 2 ones should be removed, are these 2, which are down. Oh, it's a bit hard to see, isn't it? Yeah, it's these 2. Yeah, so those 2 are gone as well. And the rest should be remaining. So you check the input sample here. See, this looks fine. 0, 0, 1 looks fine. 0, 0, 1, 0, 1, 1, 0, 0, 1, 0, 1, 1, 0s, 0, 0, 1. So that's about it. I've left some debug printing stuff here, so you can look at the actual graphs here as well. If you would like to, we could try that once. Let's see what it looks like. So now we're gonna get what? We're gonna get the islands first, and then we're gonna get the graphs, and then the island. Yeah, that ought to be good. Let's try that just to see if we can kind of get a sense of it. Okay, it's not interesting the second time because we don't update the graph, but here we can see that we have a first one is, so it's rows and then columns. So row number with the index 3 is 0, 1, 2. It's this one, and that one is connected to this one. So there we got that one. And we have a lonely one here, 4, right underneath it. And then we got the long one here, which is, so I've run this before, so I know it's this section of ones here. So let's see if it makes sense. The row should be 1. So the row on these 2 here is 1, and 5 is the column. So 0, 1, 2, 3, 4, 5. 5, and then 4, and then we're going down 1 row, which is here, and down 1 more row, which is here. It's this one. And then we do the last one, which is here. And then we have a couple of lonely islands here, the ones that are just sitting on the border, sort of 0, 0, 5, 0, it's this one, and 5, 5, it's this one. So yeah, I hope that that helps to explain it. Thanks for listening.